Hello fellow problem solvers. So today we're going to be doing a problem from the Indian National Math Olympiad 2021, problem number 1. I suggest you try this nice, decent problem out for a minimum of 20 minutes, ideally 45 to an hour and a half, not more than 2.5 hours. If you'd like to go along with us, give it a go for the next 15 minutes. Put your first ideas out on paper and now let's begin. So let's see what the problem is asking us. R is greater than or equal to 2, an integer, okay. We have 2r of these integers such that this condition is true. What if, so these, if mi is equal to mj, then they have to be 1 or -1, and the difference between these two also has to be 1 or -1. Okay, so for any integers I and j, what happens if I switch I and j around? This is the first question I'm asking myself, because I have I is less than j. Does that even matter? If I switch I and j around, this is then mj and I. No, this is the same thing. So this is just for any pair of I and j that are different, for I and j that are different from one another. This is 1, and we need to determine the maximum possible value of r. Okay, so let's try to build this up. Can we do r is equal to 2? Right, I think we can. And why can't we actually pick a large r is another way, another question. So there's two ways to go about this. One way is to say, hey, can I build up? Can I try to construct and construct and construct until I can no longer construct? Because mind you, in this problem, once you add another pair, you can use the one pair you've had from r minus 1 and then just append it, add this, and this new pair needs to satisfy all these other conditions. Maybe there's something there that it can't if there are too many conditions it needs to satisfy. And it's okay. So this is an interesting little problem. Let's try to see, does ni and mi, are they interchangeable? Like if I have mi, if I instead of say, if I exchange mi and ni for every I, does the problem remain the same? And I think it does. Because yeah, this is then ni, mj, the problem remains the same. So the actual order doesn't. So this is important to know so that we see what matters, what doesn't matter. For example, I'm now thinking if two of them are equal, what will happen? And the answer is, and I'm trying to see, it doesn't matter whether it's an n or an m that are equal, and it doesn't matter. So that's why these things are useful, to know I don't need to have two cases, it really doesn't matter. So with these first couple of ideas, I would just here try to construct for r equals 2. So for r equals 2, let's see, I can have 1 times 1 minus 1 times 0. Right, and so I'll have a pair 1, 1, and a pair that's going to be 0, 1. Okay, and then this is r equals 2. Yay! So let's try to see, can I add another pair to this? So I have to have, for this new pair, let it be AB. I'll have, if I combine AB with this, I will have that a minus b, the absolute value of a minus b needs to be equal to 1. If I combine a and b with this, I'll have that the absolute value of actually 0 times a now. Did I do this correctly? No, it's a times 1. The absolute value of a also needs to be equal to 1. If I haven't made any mistakes. Wait, can I miss? If I set a to 1, I can set b to 0, and I'm good. Yeah, that works out. So I can now have 1 and 0. Okay, I have r is equal to 3. Now can I have r is equal to 4, a new AB? And we don't know what the answer is, but it's useful to even try to construct it, because the construction might be a point or two, and that can matter a lot. So now what do we need to have? We need to have, again, for a new pair A and B, we must have a minus b is 1. the absolute value of A is 1, and now I need to have the absolute value of B is also 1. And this seems unlikely. Actually, it's unlikely due to parity reasons, right? This means A and B are both odd, but then A minus B can't be odd. So we won't be able to construct this. Maybe freeze the solution. Maybe freeze the solution. Who knows? I invite you to try to pause, and see if maybe what holds. Like pause for I don't know, say 5-10 minutes and try to see like what holds for this pair. Is there anything interesting about this triplet that holds? Maybe that can give us a clue as to what needs to hold when we plug in other things. And I hope you paused. And here's sort of, for me, I'm looking at, we're going to have, how many times am I going to have a 1? How many times am I going to have a -1? So if I combine this one and this one, I am going to have, actually, does that even matter to me? Now that I'm just thinking about it, does it matter if I have 1 times 1 minus 0 here? If I combine this one, this one, this one, and this one gives me what? And J will give me a 0. So I'll have a 0 minus a 1. Okay. If I combine this one and this one, I will get a, so M is going to be 0. So I'll get a 0 minus 1. If I combine this one and this one, I'll get a Mi, Nj, Nj, Ni, Mj. I'll get a 0 minus 1 again. I'll get a 0 minus 1 because there's a 0 minus 1 here. So maybe let's actually look at 4. What happens if I have 4? Can I use anything here? So let me take, let the first pair be AB, and then I have A Nj minus B Nj is equal to 1. I hate when they have M and N. Why don't you pick X and Y? Because I get so confused sometimes. M, N, like it's just another squibble. That's a rant. Though, what we have here is first A and B have to be relatively prime. I think that's true for any 2 that they have to be relatively prime. Yeah, any 2 numbers here have to be relatively prime. Otherwise, if say Mi and Mj had a factor other than 1, then this would be divisible by that, and it wouldn't be 1. If Mi and Nj had a factor shared, that could actually maybe work. Mi and Nj could actually maybe have a shared factor. But let's see, what does this give us? And this is really trying to just like explore the problem, not think much about this condition, just take it as is, face value. So we have, actually this is Nj minus Mj. This is why I'm saying M and N are, you see, I could have made this a 0. But anyways, we have, this is going to be, so for 2 of them, we're going to have equality. We're going to have A and J minus B and J is going to be A and I minus B and I. Due to just, what's it called? The pigeonhole principle. We have 3, they're either going to be 1 or minus 1. Now this is going to mean that A times Ni minus Nj is going to equal to B times Ni minus Nj. Actually, wait a second, I've confused them again. This is BNJ, BM, BMI, and BMJ, so it's BMI minus BMJ. So now with this, if they're equal, they satisfy this relationship. Now, A and B are relatively prime. So A divides this, B divides this. Maybe that's the route we want to go down. I invite you here to pause for another 10 minutes and see if there's another way you want to maybe look at this condition, or if there's something here that you want to explore and try to push forward. Maybe there's a 4. I don't know. But now's the time to pause, and here's the next step. Now there's a way for us to continue looking at this, and that's by saying, wait, if these are relatively prime, you have something like a times x is b times y, where a and b are relatively prime. What does that tell you about x and y? Well, it tells you that all the factors of a are in y, and all the factors of b are in x. B divides x, a divides y. And so a divides y, b divides x. Now if you set ak is equal to y, and say bl is equal to x, right? That's what divisibility means. When you put what x is and what a is, you'll get abl is bak, l is equal to k. So if a and b are relatively prime, then there exists a k such that ak is y and bk is x. And here, that could potentially be something interesting. Now we have that a times k is going to be equal to mi minus mj, and b times k is going to be equal to ni minus nj. Now, can we look at what happens when we have mi and j minus mj and I? What does this turn into if we know this? Does it turn into something that is potentially more interesting, like keeping into account all of these numbers are relatively prime? And here's where I might should pause you in 3 seconds, see if you 3 minutes, and see if you can like turn this into anything cool. And the answer is you can. You can put it into this, you know, just like take what mi is and ni is, and then you get k. You can get a k outside of the parentheses, and you get ak. Actually, ak you get out, so you get a nj minus b mj, and the absolute value is equal to 1. So this tells you, actually you can't put k can be in its own absolute value, but this means that k is either equal to plus or minus 1. And now that tells us something interesting. It tells us that a is going to be mi minus mj, and b is ni minus nj. Now mind you, if we had 7, if r was 5, or if r was say 6, we would have the same signs for many of, I don't think this would hold. We would get that 2 of these are equal, the 2 ni and mj are equal. Almost definitely. I'm almost sure of that. Now for 4, there's a little bit of a tricky situation now, but this is where this leads. And if you want to take the problem down this route, be my guest, you can actually finish it like this. And that's one way to finish it, by going down this route. Because now you need to look at the last pair. So say this was, the last pair was CD. And what needs to hold for CD? Right, what do you have for CD? You have AC, you have AD minus CB. This is 1. And then you have, what's it called? You have MID minus C. NI is 1. You have all the others which are 1. And then maybe there's a way that you can get out a contradiction from here. So this I leave to you if you want to go down this route. I want to go down the route that we were at before when we had, where we're looking at r equals 4. And we couldn't construct this. The reason we couldn't construct it was because of a parity issue. Why don't we look at parity here? Because what happens when we look at parity? We can have here, how many can we have that are even? We can have at most 1 even number, right? Because every 2 are relatively prime, which means at most 1 even, and every other number has to be odd. Actually, wait a second. We can have at most 1 m that's even, and at most 1 n that's even. Is that true? If we have an even m and even n, so actually we need to have, yeah, we can have at most 1 m and at most 1 n, which are even. And those can they be in this, and they cannot be in the same pair. So now we have two evens, two pairs which have that are of the form 2a and 2k plus 1, and another pair which is of the form 2l plus 1, 2b. The third pair needs to have everything even, everything odd, 2x plus 1 and 2y plus 1. And now of the fourth pair, if everything is odd, then we'll have an odd times an odd, minus an odd times an odd is 1. That's impossible. And that finishes up the problem in a much easier way than looking at these cases. Now, the reason I think this problem was also taken, I mean, it's number 1, so it's meant to be an easier problem on the easier side. But I think another reason it was taken was because it has a very nice geometric interpretation, which is, and that is this geometric interpretation. And it's like when I had like A and B instead of A, B, C, D, instead of M, I, N, I, it really hinted at like, you know, these use of linear algebra determinants, which are used to calculate like the area in geometry. So this is where the geometric interpretation is motivated from. And then the problem statement is how many points can you have in a plane with integer coordinates such that the areas of all these triangles, this one and we have this one, can you have really 4 points such that all these areas are equal? They're equal to half, but I think more importantly that they're all equal. And that's what the problem is. And then you can try and solve that by looking at, say you have 4 points, call these angles alpha, beta, gamma. You have these side lengths and you try to finish that up. This finishes up our problem, and as always, thanks for problem solving.